Oh, hello there. I'm the Code Whisperer. Today we're going to be making a 3D Triforce. Now we already made a CSS Triforce, but it wasn't really 3D. It was more like a 2D postcard. So just a refresher, here's what the Triforce looks like that we'll be making. It's made of these three shiny gold equilateral triangles. That's all really, and since they're the same shape, it should be pretty easy. And then we'll also make it spin around. So to make this happen, we're going to be using three.js. So three.js is this cool library written by a guy named Mr. Doob, and these are pretty funny. And it's just a library used to make 3D stuff in JavaScript. So you can see here are a bunch of examples that people did, and this is the library we're going to be using, because without three.js, your only option is to write by hand this renderer graphics code that is basically impossible to write by hand. So let's give this a big ol' do we want a div tag or anything? I'm not even sure how we'll get started. Let's just start by importing 3. Let's go to settings, JavaScript, quick add, three.js, and of course if you're not using CodePen, you are free to import 3 any way you like. So the first thing we're going to have to do is we have to make a triangle with three.js, or as we can see, not quite a triangle, but a triangular prism that's quite shallow. If we can make one of these and also easily control the way it rotates, then we'll be halfway there. So let's find out how to make a triangular pyramid. Three.js triangular prism. Not a pyramid, a prism. So this guy's got a bunch of code that basically makes a big old thing. He's got this triangle geometry. So you can make a geometry and then define the vertices of your geometry and your faces and all sorts of stuff. 3 has a face 3 utility that we'll be using. And this guy just has a handy class that you can use to make these. All right, so first things first, these examples are all talking about a scene, some kind of scene. Without making a scene, nothing's going to show up on our screen. So first we have to make a three.js scene before we make any pyramids or prisms, anything like that. Here's this docs page. It leads to nothing. All right, so here's the code to create a scene, and let's just copy this line by line, see what's going on here. So we'll start by making a new scene, const scene equals new 3.scene. And we also need a camera, const camera equals new 3.perspective camera. It would be nice to know what the other kind of cameras are, but for now we don't. This number 75 must refer to the distance of the camera. Let's change this layout. Get a bit more room going. And the example is saying to use the window inner width, inner height, but that seems kind of impractical. So we'll just hard code some numbers that are not too big, not too small. 400. 0.1 must be the camera bendiness, and 1,000 must also be a number that we will leave alone. Next, we have to define a renderer, and the renderer is basically going to take whatever our camera is going to capture stuff and pump it to our scene, but our scene doesn't know if it should draw it using WebGL or CSS or other native 3D things that might be available on a device. So we'll just say our renderer is a new WebGL renderer. And we need to define the size for it manually. Renderer.setSize. And we'll just make these the same numbers as we had before, 400 and 400. Tricky headphones. And lastly, we have to append the body with a child that is our renderer. So the renderer has a property called DOM element, which is like a magical thing you can append to the DOM. And whoa, it's a black square. That's pretty darn cool. All right, so we've made a 3 scene, which is great. But we don't understand, it's all black now, which makes me think that there's no lighting in the scene. So even if we put something in it, nothing would appear because there's no light to bounce off of it. Let's see, this guy is talking about that. That is good. So there's no mention of any light source. It's apparently saying if you just make a cube and put it in, that'll work. So let's make a cube. Hans geometry equals new 3.box geometry. 1 height, 1 width, 1 thingy. And we are going to be making triforces, but for now let's just try and get something on the screen. We'll make a material, and that will be equal to a new 3.mesh basic material, which makes sense. Meshes are how you draw 3D things. We're probably going to want to make it shiny at some point, which might be beyond what a basic material can do. And apparently this OXOOFFOO thing is legal JavaScript, which doesn't look like legal JavaScript to me, but that's awesome. Maybe it'll work. Const cube equals new 3.mesh. So basically we make a 3 mesh, and we combine the geometry, what the shape it is, with what material, how we want light to bounce off of it. Now we have to add the cube to the scene. And this guy recommends moving the camera back far enough so that we can see it. Okay, so we should be seeing a cube. We are 1000% not seeing anything. It's just black. Okay, let's look at this example some more. Scene, camera, renderer, basic mesh material. Is there an error? No. No errors. Yes, and we must call renderer.render scene. Nothing. So that doesn't look right. And then there's some mention of a canvas or something. Yeah, three.js makes a canvas in which to do its thing. And you can't really see what's going on inside a canvas because it's kind of, you can see it, but you can't change it. So what is going on here? Why is there no cube? Let's see, 3.js scene all black. So black is just the default, but why are we not seeing any cube? Maybe it's too small because we made it 400 by 400. Let's just make size const and make it 1000 instead. Maybe our cube's just hidden off screen. Size. Still no cube. Did I make an error when I defined this geometry or this material? Camera position is -5? No. Just a big black void. No, no cube. No cube. No, 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 no cube. Oh no. Ba, ba, ba. Da, 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 no. No, no cube. Whoa, whoa. Okay. It's not inner width divided. It's not inner width comma inner height. It's divided by inner height. And since our sides are the same, this shouldn't be size. Size should be 1. And okay, and you'll reward me with a cube now. Isn't that right, Paige? Ah, where's our darn cube? This don't make no sense at all. What if we make the size smaller again? Yeah, it just draws the thing. What if we never add the cube? Looks the exact same. Camera is not an instance of 3 camera. Right, so we need to attach the camera to the scene somehow. How in the heck are we supposed to do that? All right, so render scene, comma, camera. Hey, yeah, it's our cube. It's our cube. It's there on the screen. We did it. All right, so this just looks like a green square. So let's fill in the rest of this example so that it kind of spins and we can see the whole cubiness of it. So we'll make a recursive function called animate. Animate equals function. And it will call request animation frame and itself, which means the next time an animation frame comes, it's just going to do itself again and again every frame. All you have to do is say it once. And we will increment the rotation of the cube to make it appear to spin around. And then we'll call animate. And also we need to render it. And with any luck, whoa, it's a big spinny cube made of non-right material. So that's looking good. We've gotten our 3D cube. All we have to do is turn it into a triangle, make 3 of them, and make them all rotate around a center point. Oh boy, it's gonna be a rowdy morning, folks. So here we are. And I guess we'll just call animate here. So we're gonna want to make this material kind of gold looking, make it look like a gold cube. So let's work on that. three.js gold material. Let's see, is that what we want? Sure. How to apply textures, cube mapping, bricks. All right, here's the good stuff. Metal material. Mesh Fong material with an env map and reflectivity. All right, let's try a Fong material without an env map because we don't have any. Instead of mesh basic material, we'll say mesh Fong material, and that did not work. Now nothing shows up on our mesh Fong, What's wrong with that? So let's give it a reflectivity of 0.8 and that should work. Get fonged. Why are you not fonging? This does not work. All right, cool. This material would be good enough. Like a liquid gold. Material for shiny shiny surfaces. All these different options for the Fong, but when you get down to it, ours just isn't showing up. It shows up with a basic material, but with the Fong, we need an example here. Oh, this guy's got loads of good stuff going on. So you got plane, you got sphere, you got cube. So this guy's just defining a color on his Fong and nothing else. But he's also has a spotlight. That's crazy. All right, so we need to definitely need a spotlight for any of this to work. So let's work on that. Here we define the scene. Let's copy a spotlight code. That doesn't seem right at all. Change the view. That looks better. So we are going to need a spotlight. Const spotlight equals new three.spotlight, and let's make the default white. Spotlight.position.set 0, 30, 60. Sure, that should work. Spotlight.cast shadow, we want that, so that's true. We could probably leave the intensity at default, but since we've already typed it out, let's make that 0.6. And we'll add the spotlight. Whoa! Check it out! It's a shiny green cube, man. Far out, guy. All right, that's cool. All right, so let's change this color to yellow. All right, that's cool enough. And while we're at it, let's change it so that we only want the Y rotation to change. We want it to rotate slower. All right, that's awesome. So this is a very cool, very good proto Triforce. Next thing we need to do is change this mesh, change this geometry from a box geometry to a triangular prism. three.js triangular prism geometry. This gives me a triangle step, but it doesn't actually give me an example I can use. All right, this guy's created some kind of monstrously ugly thing. It does not look like a triangular prism to me. This has just gone and taken us out of three.js altogether into Blender, where it's also hard to do. So according to this guy who has the only example, we're going to need to make a triangle geometry class and then push the vertices to it and then push faces to it. And this all looks very, very complicated. But according to this guy, we just make a prism geometry function. Mesh form, prism geometry, extrude geometry. All right, so, whoa, this doesn't make any sense. We could just copy it, but that's like writing using code we don't understand. Let's just do our best, see what we can do. So we'll get rid of this box geometry, which we know works, and we'll make a new geometry, new three.geometry. Now we've got to give it 6 vertices and 3 and 4 faces. Blah, 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 blah. Should be 5 faces, actually. Const geometry. Yeah, we got no choice. We're just going to have to add all this code. So should we copy it? No, let's just write it. Geometry.vertices.materials. Geometry.vertices.push. New 3.vector3. And we'll define the x, the y, and the z. Is there an error? Do we make an error? No, that works. Now let's copy this a whole bunch of times. This should be negative 1.5. And then this should be positive and negative. Anything showing up so far? Nope. Now we need 3 more. Oh, it's going to be so easy to make a mistake on these. So this fourth one is negative 1 with the other 2 positives, but this one's a 1.2. And actually, no, these last 3 are all the same as the first 3, but it's a 1.2 instead of 0.95. Still nothing, because it has vertices, but no faces. So let's add a face. So the face seems to connect to these vertices. It's like you're defining the index of the vertices, and then it's kind of making a face connecting those vertices. So with any luck, if we just fill in the right one, it should draw something. We got an error? No, I don't think so. All the code is working right. Zero, 2, 5. And 0, 3, 5. Why is it not drawing anything? Is it off the screen? Did I make a syntax error? No, it all looks good. And we've got to make a double-sided material. Side 3 dot double side. That is apparently not a thing because nothing's happening. But if we change our geometry back to our cube, all right, so whatever. When we make it a box geometry, it's making this weird shape. It doesn't really make sense what's going on with this with this shape. It's definitely one messed up cube thing. It kind of looks like a triangle from some angles, but then again, it kind of doesn't. So let's go back to our normal geometry, and we are of course seeing nothing. Will this work? Okay, that's cool. It looks like we want something like one of these bad boys. And the view source code button does nothing. That's a tricky one. We'll just get our box geometry back since it's a comforting looking spinning gold cube that we have. Makes me feel good. Makes me smile. So what happens if we just push these faces to this cube? Is that what was causing all this crazy shape thing going? Yeah, if you give the cube more faces that don't make sense, it will just be like what we're seeing here is not a shape. There's lines that don't. It's crazy, man. So yeah, we don't want these at all. Three.js triangular prism. Maybe just three.js triangle. There's options, but they don't actually show me an example. Right, okay, this guy's using his vertices kind of in advance. I like it. So we'll define these vertices, and now let's uncomment out this. We'll actually just push the first face, and we'll keep the other faces off. Let's get rid of these second three vertices, these back faces. And we'll just use these three.vertex v1. v2, v3. We have to compute the face normals? That's nuts. Is that going to make everything okay? Are we going to see our triangle now? No, hell no. So maybe these vectors are just too far out. Let's make these ones. And we should see something. But we see nothing. Is the camera position not right? Let's try 10. 10, 10, 10. If we add some numbers to this last slot. It by all accounts should work. Maybe it's this material. Switch to a basic material. No, we're fully not seeing anything. Okay, it says don't use 3.vertex, just pass straight up the vector. And nothing appears. All right, so you need to add the vertices in counterclockwise order because sense. Vertices.push. And we still see nothing. Okay, maybe the phase should be 0, 2, 1. Nothing. All right, what's this guy going? This guy has an example. It doesn't seem to be outputting anything at all either. Doesn't even have 3 because whatever link this guy used for three.js didn't work. So I'm gonna have to update this repo just to see if this fiddle works. Yeah, no, this isn't gonna work at all. It might have something to do with my camera, might have something to do with my meshes. Add another value to the camera. Maybe this shouldn't be 1,000, maybe it should be 100. 10,000. No, sir, when you get down to it, all we got is a big old box. Big old box that don't do shit. And now we can see whatever we've done, we've made our thing really, really tiny. I think it's our camera distance. That's too close. That's just right. 10 is just right. So this is the one that works with the cube, and this massive thing with the triangular prism doesn't work. Wait a minute! By Jove, it's our triangle shape. How did that even happen? Who cares? It works. Good stuff. And we have this, and it spins nice. We spin it around Y. And we've definitely got the makings of a Triforce going. Good work, everyone. Let's see how far we can take this. So we have amazingly gotten this yellow scrap to spin around on the screen. It doesn't seem like much, but we're going to take this and we are going to parlay it into a 3D Triforce. It might take a while, but gosh darn it, we're going to do it. All right, let's change the view again. That looks just about right. Now, we need to make this more into an equilateral triangle. This is more of a right triangle. So let's start with these vertices, and that's 1 and 1. It also doesn't make sense why it's taller than it is wide, like 0, 0, 1, 0, 0, 1. So what if we make this 1, 0, and 2? What if we make them all zeros? Oh, weird. All right, so for this code, we've gotten both our vertices code from above and from the bottom. That didn't even make any sense. We just got all the code in. Let's see what's actually making it work here. All right, so it's not the face between 0, 2, and 1. It's the face between 3, 4, and 5, or V1, V2, and V3. Or no, from these weird numbers here. So what if we change V1, V2, and V3 to be the same as those? -1, -1.5, 1.2, and +1, -1.5, 1.2. Still nothing, but if we change the order to 0, 1, 2, we still see nothing. But if we have 3, 4, 5 go in here, we get our shred of a prism. All right, whatever. Let's just get rid of all this code that isn't working. This one, this one, this one, this one, this one. Now the indexes of these are not 3, 4, and 5. They're 1, 2, and 3. But then where's the first face? Nothing is rendering now. Cannot read property X of undefined. Because 1, 2, and 3 is too high. All right, good stuff. So we've narrowed it down that it's these 4 lines of code that make it work. Do we have to compute the face normals? Yes, no face normals, no shape. Let's get rid of these and massage these numbers so that they are less weird. We'll change the Z's to 0. That's looking good. And let's see, so we need x and y values to make an equilateral triangle. Can we just look those up? Equilateral triangle xy values. Could we eyeball it? What if we make this 1.5 as well? Things stop showing up. Let's see, the second value is the y. So this is the top and these are the two bottoms. So two bottoms, we kind of just want to shift them along their way. It's a little tall, so let's make these y less dramatic. All right, look at that. It's a little yellow triangle spinning around on the screen. Not quite a Triforce yet, but we're gonna get it there. We're gonna get it there. Can we move the camera closer so it just all appears bigger without us doing more work? Yeah, all right, that's nice. Maybe a little farther than that. Okay, so we got this cool flat triangle. It's spinning around like a previous example, but we want it to be a kind of a 3D flat prism. So we're going to have to define 3 new vertices. We're going to have to push them back a bit, and we're going to have to make some more faces somehow. Man, I can't believe we're trying this. There's no way this is going to work. So we'll just push all of these back to 1. So now this has the second set of 3 vertices, but they're kind of invisible. So let's try drawing just the back triangle with 3, 4, and 5. So we should see, yes, yes, it's 2 little triangles. It's working. One is way too far though, because they're kind of shallow. So let's make these 0.2. Excellent. Excellent. So that's good. So now I have to define 3 faces that connect these widgets. They're going to be 4-sided faces. So I think the first one would be new face for 0, 1, and then 4, 5. So the equivalent faces of the thing. And as you can see, we get something, but it's not quite right. 4, 6. Still wrong. 0, 1, 6. Oh, right. We want a face 4, not a face 3. Zero, 1, 4, and 5. Not quite. 0, 1, 2, 3, 4, 5. So let's try 0, 1, 3, 4. Oh, no, not quite. It's right on the top, but then wrong on the bottom. 3, 5? No. 4, 5? Darn it, we want a square face. What's so hard about that? Hmm. 1, 2, 4, 5. Is that right? Is that working? No, no, now it just seems to be on the bottom and not really doing anything good. Face 4. 0, 1, 0, 1, 2, 3, 4. Is that the right shape? Kind of looks right. No, that's just not right. Okay, 0, 1, wait for it. 5, 4. No, not exactly. It just kind of goes across 0, 1, 4, 3. No, it seems like no matter what we do, this phase 4 keeps making a triangular sort of shape. Let's look it up. 3 phase 4. This guy's having the same problem. Okay, of course. Phase 4 is removed. Don't use phase 4. Use 2 phase 3s, of course. Thank you for that obvious claptrap. So this should give us a little half triangle. And then we need to make another face to draw the other half triangle. 0, 1, 3, 0, 1, 4. Not exactly. 0, 1, 3, 0, 1, 5. No. No, still no. 0, 1, 3, and then 0, 1, 4. Can we make the spin the other way and faster so we can see better what's wrong with our darn shape? It's too fast. Right, so it's kind of drawing these two triangles. That's not exactly right. 0, 1, 4, 0, 2, 3. No, more madness. So we're sure 0, 1, 4 is halfway that we want it. Now we just want it to connect from the other side. So we don't want 0, 1, 4. We want 0, 3, 4. Bingo! Bango! There we go. So we have the makings of a gold triangular prism. Now we just need to figure out the other vertices. So that's going to be 4 more triangles that we need to draw. That should be pretty hard. 0, 1, and 4. So now I don't want 0, 1, and 4 anymore. I want 0, 1, and 3. Or 0, 1, and 5. Or not 0. Now I want to start on 1. Geometry that faces the push. New 3 dot face 3. 1, 3, 4. 1, 2, 4. 1, 4, 5. Looks like that one is on the bottom, so that's good. We'll just erase it for now. I don't even need a bottom one. It's never going to show up. Let's try it starting on 2. 2, 3, 4. No. 2, 4, 5. Still on the bottom. 2. So I want to find the 2 faces of the first triangle it touches. That's 0, 1, 0, 3. 0, 2? Great. Now you can see we finally figured out where it is on the other one. We're getting the half. Now we have to make the other one that complements it. So 0, 1, 3? 0, 4, 3. No, that's definitely not going to work. 0, 2, 4. No. Each one makes something a little different. 0, 4, 5. If we give it 0, 3, 4, it's just the same as the other one that we already made. Maybe 1, 3, 4. Whoops. Man, this is hard. So it goes from the first and the third point on the first triangle to the first point on the second triangle. We want another one that goes from the first and the third on the first triangle to the last one on the second triangle. But that's not quite right still. No, it doesn't matter what we do. It just ain't quite right. No value actually fills it in. Zero, 2, and 3, 0, 4, and 5. 1, 4, and 5. 1, 2, and 3. 1, 4, and 3. There we go. One, 5, and 1. Nothing wants to work. All right, let's just freeze the Y rotation. Right, so there is our shape. It is not right. And there's half the triangle. That looks good. So the triangle seems to be going from point 1 to point 3. No, from point 0 to point 2. 0, 2, 3. Which means that the other one should be 0. This is 3. 0, 0, 3, 2. Which means the next one should be 2, 3, something. Hey, it was 2, 3, 5. Yeah. Yeah. So if we animate it, looking good, very golden, very triangle-y, very promising. Let's freeze it again. And now we got to fill in these bottom ones. So we'll just use the same process as before. We want one that connects faces 1, 2 and 4. Good. With 2, 4, and 5. Yeah! We made a triangular prism. Only took all day, but that's worth it. Oh yeah. All right, so that was a heck of a lot of code, but now if we bring back our animation code, we can see we have our gold rotating triangle. This is awesome. This is basically 90% of the way there. Now we just have to figure out how to make 3 of them, put them in a parent, position them in the parent, and then rotate the parent and not them. That's good, and we're going to do it. We're so close, and I'm not giving up now that we've gotten this to work. Heck no. All right, folks. So we have our rotating gold triangle. It's awesome. It's amazing. We're so great. Now let's make 3 of them. So let's define a parent, because we're going to want to make 3 triangles and put them all in the parent under different positions. So 3.js transform parent. Right, so you can definitely have parents. So there's a group. So it says I can just add a mesh to another mesh, and it's like it's a parent. 3.js parent. Good, this is what I want. So yeah, you just say box add, and you got a child box. So we'll need a new mesh. We'll say const container goes new 3.box geometry. And let's make it 111 so we can see it. And so we can say scene.add container. Any errors? It's not an instance of 3 object because that's the geometry. Then we need to make a cube const container mesh equals new 3.mesh geometry and material. And we'll just define the material at the top so it's accessible to all. Container. And now we can scene add the container mesh. And there it is, that's looking good. Now the question is, can we add the triangle to the container mesh? Nice, we can. And then if we rotate the container mesh, cool, so it rotates like the parent. That is awesome. So let's see, can we make this container just not render? No. Can we make it a 0, 0, 0 cube so you just don't see it? Bingo, bango, boingo. So let's make this function that creates a triangle into its own function. Create triangle. So we can draw the triangle by calling it. Create triangle, it should be. Now what happens if we just straight up create triangle twice? As anticipated, it looks the same because the two triangles are in the same darn position. So we want to change the local transform rather than the parent. three.js local transform. Do we have a transform property? three.js parent transform. We want to transform it within its parent. So this code is basically saying we want to change the drawing of the box geometry so that all the vertices are moved, which I don't really like. So we can just add x and y values to the triangle's position, but that's so hacky. Can't we just move the whole geometry? I don't know, it doesn't say anywhere. I don't get any code hints in this browser. It makes it hard. Apparently, it has a position property. Position.x equals 10. Yeah, it looks like that changes the position, just calling the position change line. And conveniently, giving it a 1 moves it basically to the middle, so that's good. X equals 0, y equals 0. So we'll pass an x offset and a y offset. Pass them on in. Now, if we call this function multiple times with different x values, x1, y is 0, and then we'll say y is 1, x is 0. Oh, too cute, two triangles, look at them go. Oh, we're so close. Now we just got to change it up a little bit so it's all good. Let's give that, instead of 1, -1, correctly moves it below. Or now just the x offset needs to be a little bit less. 0.7? 0.5. Bingo, 0.5 is the correct number. Oh my god, look at it, it looks so complete. Ah, this is awesome. And now all we need to do is create one more triangle with the same y, but instead move it the other way. Boom! Boom! Look at it. Look at it. It's a 3D Triforce. We did it. We fudging did it, you guys. Can we move the camera closer so that it appears bigger to the eye? Yes, incredible. Now let's just fix that background so that it is white. I just want to get up and celebrate right now, but I just want to give it a white background first because it doesn't quite look right. three.js background transparent. WebGL renderer alpha true. Seems easy. So here's our renderer, and we'll just say alpha true. Oh yeah, look at it go. It's a big old Triforce. So the rotation doesn't really look 1,000,000%. Let's just try making this -0.2 so that the center of the triangle is really on the center of the shape. Looks better. It's a little bit thicker though, so let's make this -0.1 and +0.1 as our thickness. That looks about as right as it's gonna get, folks. So all we're missing is one little thing. Legend of Zelda fairy theme. Wait for it. I just want to cry right now. This is so beautiful. All right, gang, we did it. We made a 3D Triforce. It was hella hard, but we learned a lot, didn't we? So be sure to subscribe, like this video, check out the code pen for the source code, and I'll see you in the next clip. Thank you so much for watching.